This is Flowline Chronicles, stories of water, people, and the future we share. Water looks simple when it flows, from a river to a reservoir, from a treatment plant to a city tap, from an intake to a cooling tower. But behind every quiet stream in a pipe, there is a machine working. And behind every machine, there is energy being spent. In the age of climate change, this hidden energy cost is no longer invisible. Across the world, pumping systems are among the largest consumers of electricity in industry and utilities. They do not make headlines. They do not look dramatic, but they quietly decide how much carbon we emit, how much money we spend, and how resilient our systems really are. Every meter of head, every inefficiency in a pump, every poorly matched motor or control system, every time we throttle flow instead of matching speed to demand, and every time a motor is pushed away from its efficient operating zone, becomes a long-term climate and cost commitment. Traditionally, we designed pumping stations to move water reliably. Flow and pressure came first. Energy was often treated as a secondary concern. But today, that logic is no longer enough. Because when climate changes, three things change with it: energy prices, carbon constraints, and system reliability. A pump designed for yesterday's assumptions may work perfectly and still be wrong for tomorrow's world. This is the uncomfortable truth. Every kilowatt hour saved in pumping is not just an economic gain. It is a climate decision. It means fewer emissions upstream, less stress on power grids, and more resilience when energy systems are under pressure from heat, drought, or extreme demand. In a warming world, water and energy are no longer separate systems. They are one coupled risk. So the question is no longer, does this pump meet the duty point? The real question becomes, does this system belong in a carbon-constrained, energy-stressed future? Efficiency is no longer an upgrade. It is a form of climate adaptation. Smart controls, right-sized equipment, better hydraulics, and life cycle thinking turn pumping stations from silent energy drains into strategic climate assets. If we want infrastructure that lasts 30, 40, or 50 years, we must design not just for water demand, but for climate reality. Because in the end, moving water is also moving energy, and how we move it will shape both our costs and our climate future. This is not just about better pumps, it is about better decisions. This is Flowline Chronicles, and this is episode 2, The Energy Cost of Moving Water.